74,000 years ago, the sky turns black. Not for hours, not for days, for years. The most powerful volcanic eruption in the last 2 million years has just ripped open the earth on the island of Sumatra. Mount Toba explodes with a force 5,000 times greater than the 1980 eruption of Mount St. Helens. 2,800 cubic kilometers of rock and ash blast into the atmosphere. That's enough to bury the entire state of Texas under 5 feet of debris. Temperatures plummet. Sunlight dims to a fraction of its normal intensity. Plants die. Animals starve. And somewhere in Africa, a small population of Homo sapiens, maybe as few as 10,000 individuals, faces total annihilation. This is the Toba catastrophe theory, and it suggests that humanity came closer to extinction than most people ever realize. But here's the twist that makes this story truly extraordinary. We didn't just survive, we bounced back. And the way we did it reveals everything about why humans are the most resilient species this planet has ever produced. Let's set the scene. When Toba erupted, it created what scientists call a volcanic winter. Sulfur dioxide and ash particles spread across the entire globe, forming a dense atmospheric blanket that blocked sunlight. According to research published in the Journal of Human Evolution, global temperatures may have dropped by 3 to 5 degrees Celsius for several years. In some regions, temperatures plunged by as much as 15 degrees. For a species already living on the edge in tropical Africa, this was catastrophic. The evidence is written in ice. When scientists drill deep into Greenland's ice sheet, they find a distinct layer of sulfate deposits, dating to exactly 74,000 years ago. That layer tells us the atmospheric disruption was massive and global. Tree ring records and ocean sediment cores confirm the picture. But here's where the science gets controversial and fascinating. Genetic studies have revealed something called a population bottleneck in human DNA. By analyzing mitochondrial DNA, geneticist Stanley Ambrose of the University of Illinois proposed that the human population may have crashed to between 3,000 and 10,000 breeding individuals after Toba. That's fewer people than you'd find in a small town today. Every single person alive right now may descend from this tiny group of survivors. The evidence comes from our remarkably low genetic diversity. Compared to chimpanzees, who have far more genetic variation, despite their smaller numbers, humans are almost genetically identical. This suggests our entire species went through a severe bottleneck relatively recently in evolutionary terms. Ambrose argued that Toba was the cause. So how did those few thousand survivors make it through? The answer lies in 3 key advantages that Homo sapiens possessed. First, behavioral flexibility. Unlike other species that relied on specific food sources or habitats, early humans were generalists. When their usual food sources disappeared under layers of ash, they adapted. Archaeological sites in South Africa, like Pinnacle Point, show that humans living around this time period shifted to marine resources. They gathered shellfish, hunted seals, and collected edible seaweed along the coastline. The ocean, largely unaffected by the volcanic winter above, became a lifeline. Researchers at Arizona State University, led by Curtis Marine, discovered that Pinnacle Point's inhabitants were already exploiting coastal resources before Toba erupted. This wasn't a desperate last-minute adaptation. These humans had already diversified their diet, which meant they had backup food sources when the volcano struck. It's like having an emergency kit packed before the disaster even happens. Second, social cooperation. Surviving a volcanic winter isn't something you can do alone. You need information sharing, division of labor, and mutual support. The archaeological record from this period shows something remarkable: an increase in symbolic behavior. Shell beads, ochre pigments used for body decoration, and carefully crafted stone tools suggest that human communities were becoming more socially connected. These weren't just decorations, they were social technologies, ways of building trust and identity within groups and between them. Anthropologist Polly Wiesner has studied modern hunter-gatherer societies and found that gift exchange and social networks are critical survival strategies during resource shortages. When one group faces starvation, their connections to other groups can provide food, shelter, and safety. This same mechanism likely helped our ancestors survive the Toba aftermath. Groups that had invested in social bonds had access to wider support networks when times got desperate. Third, technological innovation. The period around and after the Toba eruption sees a burst of what archaeologists call the Middle Stone Age technological revolution. Humans in southern Africa began producing more sophisticated stone tools, including microliths, tiny blade fragments that could be hafted onto wooden or bone handles to create composite tools. These were more efficient, more versatile, and could be repaired in the field. At Blombos Cave in South Africa, researchers found evidence of complex toolmaking and even what appears to be an early paint workshop, dating to around 75,000 to 100,000 years ago. The inhabitants were mixing ochre with bone marrow fat and charcoal to create paint, storing it in abalone shells. This level of planning and abstract thinking gave humans an edge that no other species possessed. Now, it's important to note that the Toba catastrophe theory isn't without its critics. Some researchers argue the volcanic winter wasn't as severe as initially proposed. A 2018 study published in Nature by Chad Yost and colleagues analyzed microscopic plant remains in lake sediments from East Africa and found no evidence of catastrophic vegetation die-off after Toba. The plants survived, which suggests the environmental impact may have been less apocalyptic than the worst-case scenarios predict. Other researchers, like archaeologist Michael Petralia, have found stone tools in India buried directly above and below the Toba ash layer. This suggests that human populations in South Asia may have survived the eruption without major disruption. The tools look remarkably similar before and after the ash, implying continuity rather than catastrophe. So what's the truth? The current scientific consensus is somewhere in between. Toba was undoubtedly a massive event that impacted global climate. But humans may have been more resilient than the original catastrophe theory suggested. Different populations in different regions experienced different levels of impact. Some groups may have barely noticed the eruption. Others may have been pushed to the brink. What's truly mind-blowing is what happened after Toba. Within just a few thousand years of the eruption, humans began the great expansion out of Africa. They crossed into Arabia, pushed into Asia, reached Australia by about 65,000 years ago, and eventually colonized every habitable continent on Earth. It's as if the volcanic winter, rather than destroying humanity, actually accelerated our development. The pressure of near extinction may have selected for the most innovative, cooperative, and adaptable individuals and groups. Here's a comparison that puts Toba in perspective. The eruption of Krakatoa in 1883, one of the most powerful in recorded history, lowered global temperatures by about 1.2 degrees and produced vivid red sunsets worldwide for months. Toba was approximately 100 times more powerful than Krakatoa. The eruption of Tambora in 1815 caused the year without a summer in 1816, leading to crop failures and famine across Europe and North America. Toba dwarfed Tambora by a factor of at least 10. And yet, here we are, nearly 8 billion strong, spread across every corner of the globe, descended from those few thousand survivors who refused to go quietly into extinction. The Toba story isn't just about a volcano. It's about what happens when you push humans to the absolute limit. We don't break. We adapt. We innovate. We survive. Remarkably, Toba isn't even the only supervolcanic event our ancestors endured. The geological record shows multiple massive eruptions over the last 2 million years, and early humans persisted through all of them. Today, several supervolcanoes remain active, including Yellowstone in the United States. Scientists estimate that Yellowstone has a roughly 1 in 730,000 chance of erupting in any given year. If it did, the consequences would be devastating. But if history teaches us anything, it's that humanity has faced the worst this planet can throw at us and come out the other side. That resilience, that stubborn refusal to disappear, that's the most human thing about us.